guys, you are welcome to today's class lesson. In the course of this class lesson, I'll be teaching on a very vital aspect in the subject chemistry. Alright, so let us start right away. So pay attention. So pay close attention in today's class. You must be with your pen and your notebook so we can start right away. Alright, so we can start right away. If you can hear me, do well to signify so we can start. Alright, so because of today's class, I'll be teaching on a very vital topic in chemistry. It's a very important branch of chemistry, and it's simply called electrochemistry. All right, it's simply called electrochemistry. So let us start right away. I'm going to teach you all you need to know. All right, as far as this topic is concerned. So guys, if you can hear me, do it to signify so we can start right away. If you guys can hear me, do it to signify so we can start right away. If you can hear me, do it to signify so we can start right away, guys. If you can hear me, do it to signify so we can start right away. Alright guys, let me know if you can hear me. Let me know if you can hear me. Alright, so let us start. So we'll be discussing on this topic called electrochemistry, and it is one branch of chemistry. So there are a lot of things to learn here, and I'll be teaching you all you need to know as far as your exam is concerned. So first thing we must learn when we study this topic is a term in this aspect of chemistry called electrolysis. Class, pay attention. This is very, very important, all right? We must know what this term electrolysis is all about. So let us start. What is electrolysis? Listen. Electrolysis is simply, electrolysis is simply the passage. I repeat, electrolysis is simply the passage, it is simply the passage of something, simply the passage of something very important, and it's simply called direct current. Please pay attention. In electrolysis, it is simply the passage of direct current, and this direct current is passed through compounds, through a compound, you see, through a compound, and this compound to which this current is passing can be in two forms, through a compound in solution, through a compound in solution, or molten form, through a compound in solution or molten form. Pay attention, or molten form with a process occurring at some terminals, just relax, with decomposition, Alright, all these terms are very important with the composition occurring, alright, with the composition occurring at, with the composition occurring at the electrodes, alright? So you just pay attention, then I explain what all this means, alright? So pay attention so I explain what all this means. Class, is the network clear? Let me know. So what I just said here is electrolysis, alright? But I have to explain. It's not just by defining, you have to know what is happening in class, alright? You have to know what's happening. All these things are very, very important. You have to know what's happening. So guys, without wasting much time, I repeat that the definition one more time and not proceed. Electrolysis is the passage of direct current. We have in physics, we also have another kind of current called alternate current. But in electrolysis, what is passed? Direct current, DC. And this current is passed through a compound. If it was those that I know in physics who say the current is passing through a wire, you understand, but in chemistry, it is passed through a compound, and this compound can be in two forms. Either the compound is in the form of a solution, or the compound is in molten form. Just pay attention, alright? And then I said something, with a process called decomposition occurring at, but before I do that, let us proceed. Everybody note this. This process, which is called electrolysis, it occurs in a special vessel or a special container called something. Everybody note this. Electrolysis occurs in a special vessel. Electrolysis occurs in a special vessel called the electrolytic cell class. In this aspect of chemistry, we have two kinds of cells. We have electrolytic cell and also electrochemical cell. Are you there? As we proceed in this class, I'm going to differentiate these cells. But before then, you should know that electrolysis occurs in a very special cell called what? The electrolytic cell. I'll be giving you guys a diagram of this cell very soon. Alright? So you should note this. I'll tell you what this electrolytic cell does. Alright? Pay attention. As a student, you should know here that the electrolytic cell converts something to something. I repeat, the electrolytic cell converts something to something. They can ask you this in your exam. They can ask you, what does the electrolytic cell convert? It converts electrical energy, which is a form of energy, electrical energy, which is a form of energy, to chemical energy. I repeat, alright, it converts electrical energy class to what kind of energy? Chemical energy. Are you guys following me? Please note all these are very, very important, alright? So without wasting much time, let's get straight into the diagrammatic representation of this cell called the electrolytic cell. You have to know the components of an electrolytic cell. So you must pay attention, class, alright? So let me draw an electrolytic cell for us so we know how it looks like. So listen everybody. This is how a typical electrolytic cell looks like. Pay attention. Listen and listen well. most importantly, you should know the component of this cell. What makes up this cell? Are you there? That's the most important thing you must learn here as a student. What makes up this cell? Alright, what makes up what? This cell. That's the component, because this is where questions come. They can actually give you a diagram of an electrolytic cell and they will tell you what is this, what is that. You understand? So that is what we'll be learning right away, guys. That is what we'll be learning right away. So you guys should get ready to learn all these. Alright, get ready to learn all these. I'm trying to make it equal. Alright. So we have another one coming down like this. Are you guys following me? Alright, so let me put something here. Class, just pay attention, I'm not done. These two stuffs, alright, that is flat in this diagram is placed in a container. These two stuff you are seeing, I'm going to tell you what they are. They are inside what? A container. You can see the container. And inside this container there is something, alright? But before then, let's just finish this stuff. You understand? And this is an arrow moving in this direction. Now let's start labeling, class. Let us start labeling. This thing we are seeing is where the current is coming from in this cell called the electrolytic cell. And what will I call it? I will simply call it the direct current source. I repeat, the direct current source. Alright, the direct current what? Source. This is the direct current source. Class, can you hear me? This is the direct current source. Now, this current is moving from here, and you can see the direction. Current flows in one direction. Be it is physics or chemistry, current always flows in like one direction. It flows in the direction of what? Like in opposite direction to the source. It flows in opposite direction to the source, like you get. This is the source, so current will not flow towards the source, it will flow away, you understand? And comes like this and enter into these terminals. These things, we call them terminals. Are you there? And what are they? One of the terminals is positively charged, while the other is what? Negatively charged. Class, pay attention. These terminals in this cell, we simply call them electrodes. I repeat, what are they called? Electrodes. Because I told you that as soon as this current is passing through any compound that can undergo electrolysis, this compound, we already know that it could be in a solution or molten form. There is a process that is occurring at these terminals, which I'm going to stress on when we move further, and it is called decomposition. So as soon as this current is coming, there is something of these terminals are undergoing decomposition. Decomposition means breakdown. Because current will actually have the ability to break down these terminals. Just relax. And these terminals, we simply call them what? Electrodes. Are you guys there? So electrodes are of two types. Electrodes can be anode, and electrodes can also be cathodes. So in this aspect of chemistry, pay attention. Listen and listen well. If you are asked, what is the charge? Listen, they can just ask you now. In an electrolytic cell, which of the terminal is positively charged? And also, which of the terminal is negatively charged? Just note this, class. This one that is positively charged, this terminal or this electrode that is positively charged is simply called the anode, while this that is negatively charged is simply called the cathode. Are you there? This anode and cathode, they are all embedded in a fluid or a liquid substance. Class, listen. This liquid substance, which we are going to talk about as we progress in this class lesson, we call them electrolytes. Alright, what do we call them? We simply call them what? Electrolytes, and we explain. But for now, everybody, this is a typical diagram of an electrolytic cell. You just listen and draw what I just drew on the board so we can move further. Alright, this is a typical diagram of an electrolytic cell. Class, can you hear me? If you can hear me, let me know in the comments. If you can hear me, let me know in the comment section, guys. All right, very good. So we can move forward, guys. Quickly draw what you're seeing, guys. If you guys can hear me, let me know in the comments. Can you guys hear me? Let me know in the comment section. Is it clear now? Is it clear now? I had to quickly log on my other phone so as to be able to see the class. Class, you guys should respond on time, please. All right, very good, very good. I can watch it on my other phone. Look, here is it. I had to quickly just log in on my other phone. So guys, I'm so sorry about that, guys. I'm so sorry about the network problem. I just hope it's not going to happen again. All right, it will not happen again, guys. So let us move further. I'm monitoring the class here on my other phone, so if there's any problem, I will get to know. So as I was saying, there is also a switch here or a key. All right, when it is like this, means that the circuit, this is a circuit, is opened. You understand? The current is flowing. You understand? That's what that means. That's a key. You get what I'm talking about? So that is for that. That is for that. All right. All right, let us move further. Let us move further. I'm coming, guys. Okay. Oh, hold on, guys. Hold on, guys. Hold on. So I can, quickly. All right, let's get it straight, This is the key, all right? When it is like this, it simply means that a wire in the circuit that, is broken, all right? So there will not be any current passing. Do you understand what I'm saying? When it's like this, it shows that there is a circuit that is broken in physics. It's still relatable though. There is no current passing, but when it's closed, that means there will be current passing. You understand what I'm saying, guys? So that is for that. Just get it straight. All right, just get it straight. Just get it straight. Just get it straight. All right, so we can move further. So, guys, now if you observe, I mentioned a term called electrolyte. What is an electrolyte, everybody? Pay attention. This is very important to note as a student. JAMB exam asks it a lot. Any chemistry related exam, they ask questions on electrolytes. So the question will ask herself, because I have told you already that electrodes are anodes and cathodes, and these are the guys, right? But let us stress on electrolytes. So I'll be wiping the board so we can start properly on what electrolytes are, so get to understand, everything that is happening. All right. So we get to understand everything that is what happening, guys. So we get to understand everything that is what happening. So what are electrolytes? Then what? What are electrolytes? Class, please, all these informations, they are very, very vital. So you should pay attention, all right? So that is for that. So let's go. What are electrolytes? What are electrolytes? Let us start right away. All right. So let us start. What are electrolytes, everybody? Very easy. Electrolytes. What is an electrolyte? Listen, class, meanwhile, as I teach, any part you like in the class, you can, maybe you're watching it on the TV, you can quickly do a short video for me and send to me on my WhatsApp. You're watching it on your laptop, you do the same and send to me on my WhatsApp, alright? But not now, let me just write on the board So electrolytes, they are compounds. I repeat, electrolytes are compounds. Electrolytes are not elements. So whenever you talk about electrolytes, your mind should be going over to compounds. Now listen, electrolyte is a compound. Listen, electrolyte is a compound that conducts electricity. Alright, electrolyte is a compound that conducts electricity. So I'm not done. So for you to get, normally now metals conduct electricity, all of those things in physics. In physics, right? I believe you've heard this definition before. But I know the one you are hearing is not exactly this. There's something that conducts electricity. And what's that thing called? Hold on. But in chemistry, we have some certain compounds that have the ability to what? Conduct electricity. And these compounds, we call them what? Electrolytes. But they don't just conduct electricity anyhow. Do you understand? They only conduct electricity when they are in a particular state of matter. Remember, on the state of matter, I talked about 7, but we stress on 3. Are you there? So out of the 3, they basically conduct electricity in one of them majorly. Alright? Conduct electricity in liquid. I repeat, in liquid form only. In liquid form what? Only. So for you to be an electrolyte, you'll be able to what? Conduct electricity. And the form to which you are conducting electricity is what? Liquid form. You must be liquid before you can conduct what? Electricity. And before we can call you an electrolyte. So it is not all kinds of compounds that are electrolytes. Are you there? Pay attention, guys. These things are very, very important. Now, moving further. In that definition I told you guys, you already know those ones, they are not called compounds, they are elements. Elements that also can conduct electricity, those guys, we simply call them conductors. What did I just say? Those guys that can conduct electricity, but they are elements. Are you there? We simply call them what? Conductors, and not compounds. I believe you guys are following me. Now, note this thing. It is very, very important. All right. Note this point. I'm about saying it is what? Extremely very important. Well, let me ask. Somebody said something. Water is an electrolyte, right? Exactly. All right. Water is an electrolyte, but you should know exactly what kind of electrolyte is H2O water. Are you there? But before then, let us move further. Listen, listen. For you to be a conductor, you will conduct electricity. But not these conductors, they are elements, alright? They are not called what? Compounds. Also, they conduct electricity, but they conduct electricity in any state of matter. So you can see now that I have basically differentiated between an electrolyte and a compound. Sorry, an electrolyte and a conductor. For both of them, their similarity. They both conduct electricity. But one of them conduct electricity in liquid form. Another conduct electricity in any state of matter, be it solid, liquid, or gas. Are you there? Like all of those metals, you know, iron, all those things, most of them, they are conductors. Do you understand? Because when you touch iron and there's electricity passing, it will actually shock that person. Do you understand? And iron is an element. So conductors, all of them are elements. Are you there? So guys, pay attention, all right? Conductors are elements that conduct electricity in what? In what, guys? In any state of matter, all right? Any state of what? Matter. Now, these are like key differences between them, so we can move further. So guys, let's get straight into the types of electrolytes. All right. There's something I want to say. The way electrolytes conduct electricity. Let me explain. I will stress on this thing when we move further, but note it for now. The way electrolytes, they conduct their electricity. They conduct their electricity by means of ions. I will explain that when we go further. The way they conduct their electricity is by means of ions. But the way these guys, they conduct their electricity is by free electrons. I repeat, by free electrons. Just note it for exam's sake. Alright, as we proceed, I will stress on them. Alright, so you get to understand what I mean by all this. So you get to understand what I mean by what? All this. Alright, that is for that. So guys, without wasting much time, let's get into talking about the types of electrolytes we have. Alright, we have two types of electrolytes. Electrolytes have types. What are they? We have strong electrolytes, and also we have weak electrolytes. We have strong electrolytes and weak what? Electrolytes. What are strong electrolytes? Class, it is same thing I taught you guys on strong acids and bases. Before I progress, anybody in the comment section, what is a strong acid? Tell me. I have taught you guys. For an acid to be strong, what does that mean? Let me know if you know that in the comment section. For an acid to be strong, what does that mean, guys? What does that mean for an acid to be strong? For an acid to be strong, guys, what does that mean? I'm waiting. I'm waiting for you guys. Tell me, try. Exactly. Somebody just said something. He said that for an acid to be strong, it simply means that that acid ionizes completely in water or a solution. That's what I mean by strong acid. I taught you guys. Listen, it means that that acid, the full acid itself, breaks completely in a solution. The way salt will break or dissolve completely in water. That is how strong acid, they dissolve themselves in a solution. And that definition you just said is the same definition for strong electrolyte. A strong electrolyte is it a compound or an element? Is a compound that ionizes completely in what? A solution. Write that in your notes. A strong electrolyte is a compound that what? Ionizes completely in a solution. Just listen and listen well. Alright? Is a compound that ionizes completely in a solution. That ionizes completely in a solution. Just write this and then I will explain further. I'm going to explain further. Alright? I'm going to explain further. You just listen. You just listen. So I can move further. Alright? Alright, guys. Alright, so that is for that. Okay. I'm coming, guys. Class, I believe you guys can hear me and the network is okay, right? I believe you guys can hear me and the network is okay, right? Alright, very good. Guys, let me know now. Let me know if you can hear me. Alright, good. Alright. Okay, I'm coming. I'm coming, guys. So we can move further. All right. So, if you want to define a strong electrolyte, we have done it already. If you want to define a weak electrolyte, it is the direct opposite of what we just said. All right. So, guys, I want you guys to tell me if the opposite. Okay, what's the opposite of completely? Please tell me. A weak electrolyte is a compound as well. All right, is a compound that ionizes. I'm going to give you reactions to back all this up. Ionizes partially in a solution. That ionizes what? Partially in a what? Solution. This is a weak electrolyte, all right? Exactly, Chibueze. Is it Chibueze? Yeah, Chibueze. All right, very good. Very, very good. Eh? So we can move further. All right. All right. Now moving further, guys, because this is where exam questions can come. Thank God I taught you guys acid, base, and salt. So I believe before you came here, you have watched that lesson. But if you haven't, try your best possible to go and watch it, the acid, base, and salt video lesson. Are you there? Now, what are examples? Because these where questions come. They can ask you, which of the following is a strong electrolyte and which of the following is a weak electrolyte? Guys, listen. For strong electrolyte, let us start. For strong electrolyte, everybody. Strong what electrolyte? What are they? They include strong acids. Acids that are strong. They include strong bases. Only thing that is a base that is strong. And also they include salts. I believe you watching me here, I've watched my lesson on acid, base, and salts. I gave examples of strong acids, like the likes of HCl, hydrochloric acid, like the likes of HNO3, hydrogen, HNO3 name, listen. Hydrogen, how many oxygen do we have? 3. So hydrogen trioxo, nitrate 5. To know why it is 5, I'm going to teach you guys on redox. Alright, to know why it is 5, I'll teach you guys on redox reaction. But I'm just going to give you examples of compounds that are strong acids, that are strong bases, so you get to understand what is happening. Alright? So anything you can think of that is a strong acid, will be a strong electrolyte. Anything you can think of that is a strong base will be a strong electrolyte. What are examples of strong bases? Like those sodium hydroxide, like those potassium hydroxide, KOH. All these are strong bases. There are a lot of them. But these are common ones, so you should note them. What are examples of salt, everybody? Like sodium chloride, like ammonium chloride, NH4Cl. I taught you already. NH4 is ammonium, Cl is chlorine. But when chlorine is in a compound, it is not called chlorine, but rather called chloride. So NH4 is called ammonium chloride. All these are examples of what? Strong electrolytes, all right? All these are examples of what, guys? Strong what? Electrolytes, all right? So that is for that. Even some certain kind of salts are also strong electrolytes. But you just group it like this so that at least to some extent, you will understand what is happening, guys. These things are not hard, they are easy. That is for that. So this is a group. Don't worry, we're going to answer questions very soon, so get ready. What are examples of what weak electrolyte? Let us start right now. What are examples of weak electrolyte? Let us start. All organic acids. I believe I talked about that in acid base and salt. We have some acids that are organic nature. Like also acid present in your orange, ascorbic acid, acid present in lime and lemon, citric acid. All those acids are organic. What does it mean to be organic? They are natural, they are rich, they are real, they are natural. A good example is this acid. They call it acetic acid. Now, don't worry. When we start organics, you get to know what this actually means. Acetic acid, you don't know it before, know from today. Its chemical formula is CH3COOH. And acetic acid is also regarded to be called ethanoic acid. So if you don't call it acetic, you call it ethanoic acid. And this acid is also an uric acid, which is this. Are you following me? So all organic acids are weak electrolytes. Most of them, they are literally weak electrolytes. Are you guys following me? So guys, moving further, we have ammonia is a weak electrolyte. All right, ammonia, which is what, guys, you can maybe video now and send to me on my WhatsApp. Some interesting part of the class, video and send to me on my WhatsApp. If you are watching on a TV or a laptop, all right. So that is for that. So this is ammonia, NH3. NH what? 3 is a weak electrolyte. Water, H2O. A weak electrolyte as well. There's a certain kind of compounds, we call them amines. We're going to learn about them very soon in organics. They are also, even if you don't now know that they are weak electrolytes. All these are questions tested by the JAM exam. That's why I have to bring them here. Are you guys following me? So that is for that. So these are common examples of weak and strong electrolytes that you will likely see in exams. But don't worry, after the class lesson, we'll tackle some practice questions. So we get to master all these happening. Alright, so we get to master all of these what happening, guys. So that is for that. So let's get straight into discussing about what, because the opposite of electrolyte is what? Class, what do you think will be opposite of electrolyte? Because we have been discussing about electrolytes. What is the opposite? It is non-electrolytes. We have some compounds that are non, because it is not all compounds that can conduct electricity in liquid form only. We have some compounds that do not, and these guys, we call them non-electrolyte. What I say, non-electrolyte. So since these guys are the guys that are electrolyte, so most other compounds will be non-electrolyte. There's a lot of them. But I'll give you some list of compounds that exams have tested. Do you understand? So we're working about to discuss about non-electrolytes. Are you there? Non-electrolytes. So guys, get ready. Non-electrolytes. So we're working about right away. Please pay attention. All these are very, very important. Alright? This list I'm giving to us, guys, extremely very, very important, guys. Alright? So that is for that. So let's discuss about non-electrolyte. Who are these compounds called non-electrolytes? Non-electrolyte. Who are they? Who are these guys? We call them non. Who are really they? Who are this set of compounds called non-electrolyte? You guys should pay attention. Let us work on them. Who are non-electrolytes? Alright? Who are non-electrolytes? Alright? Who are non-electrolytes? So let's play with them, guys. Let us play with them. Hope it's clear, guys. Hope everything is going well at your end. Non-electrolytes. Non and what electrolytes? Who are this set of compounds? Now pay attention. Now listen. Non-electrolytes are compounds that what can tell me? Because electrolyte, they conduct electricity. So what will non-electrolyte do? Please let me know in the comments.
Me, I am electrolyte, I conduct electricity. Now this time around, I am known. What does that mean? Don't put my hand, guys. What does that mean? Tell me. Alright, what does that mean? What I do my other brother electrolyte, they conduct electricity. Me, I am known. I am against them. You understand? Alright, I'm against them. So who are these guys? Alright, who are these guys? Let me know, guys. Let me know in the comments. Alright? Let me know in the comment, guys. Let me know in the comments. Who am I? I'm not the who am I? Not like electrolytes are compounds. Alright, are compounds that do not conduct. Guys, video for me or send to me on my WhatsApp. That do not conduct electricity in liquid form. Literally, even if in liquid form only, you understand? So they don't. Do you understand? They don't. What are examples? E.g. sugar. Your sugar, they don't conduct electricity. Another example, urea, which is one of the components of your urine. They do. I'm giving you examples that exams are tested. Do you understand? So these are guys that do not. You understand? Urea. There's another ethanol, which is an alcohol. All right, ethanol as well. Ethanol is a component of alcohol. All right. I'll teach you in respiratory system for those in biology. All right. Ethanol is what is produced during alcoholic fermentation in anaerobic respiration. All right. Most various organic compounds are okay, various organic, meaning that they are non-electrolyte. Another one, which is CCl4. How is this one pronounced? The name is, how many chlorine? 4. So it's tetrachloro. And this compound is formed from a methane. So it is called tetrachloromethane. Why? It is formed from a methane. It looks like methane. Methane is CH4. Alright, so what happened here? They removed all the hydrogen and replaced with chlorine. So it is still formed from a methane. That's why its name is what? Tetrachloromethane. Alright, tetrachloromethane. Class, did you get what I just said? So that at least to some extent you get why that guy is called tetrachloromethane. Not that I'll just tell you things that you get what I'm saying. Guys, let me know if you're following the comments or guys, are you following me in the comments? Just let me know. Alright. Even this guy, it is known because it is organic. I'll teach you this now. You've been hearing about methane now. It's in organic chemistry. We're going to learn it. They're all easy. So you guys should pay attention. Chemistry is easy. Just pay attention, alright? So these are for non-electrolytes, alright? These are for non-electrolytes. So now let's get into something very important, eh? We call them electrodes. What did I say? We call them what? What are electrodes, everybody? We call them electrodes, eh? Remember, I started this class by explaining what they are in that diagram we saw. What are electrodes? Let us play with these guys called electrodes. Now listen. Electrodes are terminals, right? Electrode is a very key term to learn. Electrodes, what are they? Electrodes are terminals, like in your battery. We have terminals, alright? They are terminals through which current enters and leaves a cell. These are terminals through which current enters and leaves a cell. Through which current enters and leaves a cell. And the cell we are talking about, they are electrolytic what cell, all right? Through which current enters and leaves what a cell. And the cell we are discussing about is what an electrolytic cell. Class, we also have another kind of cell that looks like electrolytic cell, and I believe I've talked about that initially. The cell we are interested in is electrolytic cell. We have another cell, this one here, they call them electrochemical. As we proceed, we'll learn about them. So, it's not just always an electrolytic cell. It can also be an electrochemical cell. Electrochemical cell. Do you understand? It can also be what? Electrochemical cell, which I'm going to show us how these cells actually looks like. Are you guys following me? I remember I told you these terminals are two. And what are they? We have anode and cathode. There is something I have to tell us, we must pay attention. Class, listen. In an electrolytic cell, the anode is positively charged. Me saying plus V here simply means positively charged. Anode in electrolytic cells, what charge? Positive charge. What about cathode? Negatively charged. All these are for which cell? Electrolytic cell. But when we move over to its elder brother, they are, listen, it is the opposite. The way anode, class video for me and send to me on my dear please. The way anode are positively charged here for electrolytic cell. For electrochemical cell, that is the opposite. For anode in an electrochemical cell, they are negatively charged, while cathode, they are positively charged. You will see all of this in the diagram when we're going to talk about them because of this class lesson. So listen and open your ears, all right? All these are very, very easy. They are not difficult at all, guys. They aren't difficult at all right? So that is for that. Moving further, there is a very key thing I want to tell us in today's class. Remember, we're going to practice some questions. But before then, let us learn. Guys, note this thing I'm about telling you guys. Note it. There are series of processes that occurs in these electrodes, which are two anode and cathode. So remember this, I use an acronym called CRYO. CRYO or CRYO. The C here means cathode. The R here is a process. It means reduction. In redox, I will tell us what this means. But in this class, I will say explain before we get to that redox. This anode, this A is anode, and the O is a process called oxidation. What does this tell us? It tells us that the cathode of any cell, be it electrolytic or electrochemical cell, they always undergo a reaction called reduction, because cryo, cra goes together, AO goes together, AO, you understand? Whereby anode, be it electrolytic or electrochemical cell, they always undergo oxidation. I believe you guys are following me. They are all very, very easy. They are not difficult at all. Are you there? So that is for that. That is for that. That is for that. That is for that. All right. All right. Let us move further.
Let us move further. We are about entering a very interesting part of this class lesson. All right. This one there, people are so scared of it, but it's very easy. All right. Students are so scared. I don't know why they are scared. But the thing with this alone, Jama asked question. So they said, which of the following reaction does cathode undergo? They listed so many things. What is the answer? Reduction. If, for instance, they ask you this way, which of the following reactions does anode undergo? What would you say? Oxidation. Remember, I'm going to tell us what they mean, not just you saying it. You have to know what they actually are. But before that, let us get into a new subheading in the course of this class lesson, and it's simply called mechanism. Mechanism of electrolysis. How does this electrolysis works? Let's get straight into the aspect. Mechanism of electrolysis. All right. So let's move further. Let us move further into mechanism of electrolysis. So guys, I'll be wiping the bottle, we'll get into that. Mechanism of what? Electrolysis. Mechanism of what? Electrolysis. Pay attention, no. Pay attention, no. This part now is very important. Questions comes out a lot from this aspect. So I want us to pay attention to this called mechanism of electrolysis. All right, mechanism of what? Electrolysis. How does this work? How does this work? Subheading. Mechanism of electrolysis. Anytime you hear mechanism, it has to do with what exactly is happening in electrolysis. Though I have told us that in electrolysis there is direct current being passed through a compound which could be in solution or molten form, with decomposition occurring at the electrodes, that is fine. But what are the series of processes that are occurring for this electrolysis to be achieved? There are three processes occurring. Let us get straight. Number one process, we call it migration. I'm going to explain what this means. But before then, right, migration. Another process is called after migration, the ions, no, not really migration. The first one, they call it what's it called? The first one is called ionization, guys. No migration, just relax. It's called ionization. All right, ionization. All right, so the first process, they call it what? Ionization. After that, the next process is called migration. Number two process. And number three process or step is called discharge. But before we get into all of this, we have to know some key points. I'll give you guys some very key information, all right? So I want you all to pay attention to what I'm about saying. I want you all, so just have this in mind that, in electrolysis, so these are the three things that are occurring, all right, which are what now? Ionization, migration, and what now? Discharge. But before then, we have to basically, learn some things, some appreciative aspect on this concept, some key information which I'm about, bringing out. So you just hold on a little bit. Hold on, guys. Hold on. Hold on, guys. All right. All right. Okay. All right. I love these questions I'm having here. Just hold on. Hold on, guys. Hold on. Hold on, guys. All right. Now, everybody listen and listen well. And when you are, because before we learn these aspects, we have to understand those. I told you that in electrolysis, the compound that performs the electrolysis could be in two forms. Could be in a solution form and also could be in a water form. Oh my God. Should be in solution or molten form rather. So let's give an example, guys. Listen and listen well. Leave this where we're coming, alright? When you see basically a compound that looks like this, they called it, the compound's name is called molten. Class, listen, molten sodium and chloride. What does this mean? Hold on. And you saw another form of a compound like this. That compound is still sodium chloride though, but this time around, they did not add molten to the name. They just called it sodium chloride solution. What did I say? They just called it sodium chloride solution. Are you there? They called it was sodium chloride solution, guys. Solution was at the end of the name. Listen, this one that is just molten alone is sodium chloride without water. I repeat, remember, sodium chloride chemical formula. Sodium is Na, chloride is from chlorine and it will be Cl. So, for molten form of any compound, it is just that compound without water. But when a compound is ended with solution, it is going to be that compound NaCl and water H2O. Class, pay attention. So whenever a compound is in the form of a solution, it simply tells us that it is that compound and water. But if it's not, it's just molten, it is just that compound standing alone. Are you guys following me? All these things are very important. Alright, so moving further, can we move further? This is another, we call it copper sulfate. Alright, copper sulfate. Copper sulfate solution. Specifically its name, because I have to say teach you guys something here. Alright, so at least to some extent you understand. Specifically it is copper 2 sulfate. Alright, copper 2 sulfate solution. Hold on. And another which is molten copper 2 sulfate. Class, listen, this is very easy. You guys should pay attention. Molten copper 2 sulfate and copper 2 sulfate solution. Class, pay attention. Look at, as a student, see, that's why I will teach you guys chemical bonding very soon. Alright, but before then, listen. Copper 2 sulfate solution. What is copper? What is the chemicals? Let us form, because I know sodium chloride is easy to just get the chemical formula. What I want to do is to determine the chemical formula for copper 2 sulfate, at least so that you understand what is happening. I don't want to just write it. I want to teach you guys how it works. Some persons here might know it. Some person might not. So what is the chemical formula for copper 2 sulfate? Everyone listen. This is copper. And they specifically told me that this copper is copper 2. Alright? It could be copper 3. But there is nothing like copper 3 though. Some elements can have a particular oxidation state and also another oxidation state. With an iron, for instance, exists in two forms. Iron basically is iron 2 and iron 3. See, listen, iron could be iron 2 or iron 3. Why? Why is that so? I taught you guys a periodic table. Yes.
I told you guys that iron is a transition metal. Those ones I wrote down. And I told you guys one of the characteristics of transition metal is that they basically have variable oxidation state. This is what I'm talking. Variable means that the oxidation state varies. It could be a number, it could be another number. But copper is also a transition metal. There could be another form of copper though. You understand? You get what I'm saying? But this time around, the copper here is copper 2. So I've noted it down. And they said sulfate or write it. Now, as a student, you should know the symbol for copper. What is copper? Copper is Cu. But specifically, they told me that it is copper 2. Then it will be Cu2 plus. Now, as a student, you should know the chemical symbol for sulfate. You know, in chemistry, when you see things, you just learn it. This is sulfate. It's a radical, which is SO4 2 minus. Class, what are radicals? Radicals, they are compounds. I repeat. Radicals are a group of compounds that are held by a charge. Like many elements coming together definitely going to form a compound. And the charge holding this SO4 together is -2 charge. Are you guys listening? Listen, pay attention. So, how do you know from the chemical formula for copper 2 sulfate? Very easy. Exchange your charges. But specifically is the number that is moving, not the signs. Alright, let us move the number. So 2 was here, it will come down here. This 2 now was here, it will go here. So when that happens, we're going to get Cu, the 2 has come here, the 2 has come here, Cu2. Now this 2 here has come here. So first it is SO4, but the 2 has come, so it's going to be 2. But to be able to write it properly, we use a bracket to separate them. So that shows that this 2 is actually affecting only this SO4. Class, listen now. Showing that this 2 is only affecting one SO4. Now, we are not done writing the chemical formula for copper 2 sulfate. You guys should pay attention, Due to the fact that both of them, the charges we moved, they were the same. It shows that we can actually still further break down this compound to form CuSO4 only. So this is copper 2 sulfate, guys. Why? For instance, it wasn't the same number. I will leave it like that. Let's say here was 2 and here was 1. I will leave it like that. Let's say here was 3, here was 4. I will leave it like that. But due to the fact that they are the same, we can bring it down to its empirical form. I have taught you guys empirical and molecular form, so you should understand what I'm talking about. Because compounds should always be in their simplest form. Are you guys following me? Guys, note this thing now. It is very, very easy. So before I move further, I want to know if you guys are following, if you guys understand what I just said. I want to know if you guys just understood what I just said. Let me know in the comment so we can move further. Let me know in the comments so we can move further. Let me know in the comments so we can move further, guys. Let me know in the comment section so we can move further, because I want to give you guys your own to work on now. I want to give you guys your own so you guys work on it. So guys, based on what I've explained, tell me, copper 2 sulfate solution rather, what are the components? And what is the component of just this one, which is a molten copper 2 sulfate? Tell me in the comment. Put the answer in the comment section, guys. Do it for me, because we need all of this information very soon. So do it for me, guys. Do it. I'm waiting. Copper 2 sulfate solution and copper 2 sulfate and molten copper 2 sulfate. Which one is the other? What are the components? At least you know the compound. Now you should don't write water is not a problem. Water is H2O. That one is easy. So you guys should tell me what is really happening. Tell me the components of each of them. I'm waiting for your answers, guys. I'm waiting for your answers. I am waiting for your answers, guys. Tell me the answer in the comments. I'm waiting. No time. Don't waste time. Don't waste time. Sorry, I did not get. Please, others respond. I did not get what you said just now, please.
All right. All right. All right. Very good. Very good. Very good. Very good. So let us move further, guys. Exactly. So copper 2 sulfate is copper sulfate, CuSO4. All right. I believe everyone know how it was gotten, and what? Water. And what? Water. And water. All right. CuSO4 and what? Water, guys. So note that. All right, guys. Let us move further. Molten copper 2 sulfate, it is just a copper like this, CuSO4. You get it, right? Without water. Without what? Water. I know why I'm doing all of this. I want you guys to be familiar with all these first. I want you guys to be familiar with all of these guys. Okay, all right. Now, I want to wipe the board. I want to wipe the board and tell you guys something very important. Because one thing is to know how compounds are formed, another is to know something. So guys, moving further, with the example I have given to you guys so far, let me teach you guys something. Because you have to know how to basically break them to form ions. Because that is one of the steps in the mechanism, which is called ionization, forming ions. But before then, you guys should listen. See, sodium chloride. Okay, everybody listen. See. For this one that is sodium chloride, all right. I hope you are aware that if you want to break sodium chloride now, you want to break it. This is what you get. You will get Na+1 because see that's why. See, okay, I will teach you. I've done it already on metals. Don't worry, that video I'm going to send to you guys so you guys understand what I'm talking about. I've taught metals and non-metals already. Like it's in a video already. Alright, but before then, just listen. So you know why sodium is actually +1? There are reasons why these guys are like this. Alright, it's in metals. I've done that already. Alright. So moving further, if you want to break sodium is +1, Na+1. Plus chlorine, it is Cl-1. Now this is why both of them, when we basically want to form the compound, because if look at it, Na+1, Cl-1. That is why they're actually like this. Look at now. Move your charges. It's going to be Na1, the one that's come, and the one that's gone here. So Cl1. So if you observe, and anything I thought the empirical and 1 is nothing, so it's simply just for NaCl. So at least to some extent, you should know the charges to be formed whenever you want to break compounds, guys. Due to the fact that these things is easy, these things are easy. Because I want us to, even if you don't really know the aspect of what I taught, which I'm going to teach you guys on metals, I've done the video already. At least to some extent, I want you guys to know the charges of compounds, like the charges of the component of the compound. To some extent, look at it, you can know it. You looking at the compound, you can know the charge in here, because you know that there is one that always exchange. But due to the fact that look at NaCl, so definitely there is no good number. That means both of them is 1, and the charges is 1. Definitely is a metal. Oh, metals are positively charged, non-metals are negatively charged. So one will be plus, one will be minus for sure. And most times the one that is written first is the metal. But leave that alone. But I want you guys to know something. You can see what I've done. If I want to write something, I want you guys to think. Look at now. Due to the fact that I did not say any number, I know that both of them were 1 because I now came down and had to like exchange the 1 thing, 1 charges I just thought of, and then we got that same compound back. So class, I want you guys to pay attention. I want to wipe the board. You listen. I want to wipe the board and say something alright. I want to wipe the board and say something that is very, very important. I want to wipe the board and say something that is very, very important. You guys should pay attention. Pay attention. Listen. Let's say we have this guy, which is calcium chloride. Me, I know that calcium chloride is CaCl2. I know. I'm aware. Class, what becomes the charge? It is very, very easy. Before these guys even came, even if you don't know the charge inside your head, but you can get it with the compound.
Because you're already aware that it is exchange of their charges that form the compound. So definitely just the fact that chlorine has 2 here. It is calcium that gave it to chlorine. It is calcium that what gave it to chlorine. So actually this is how they were initially. Calcium that gave it to chlorine. And when you see all of these things, you should not forget again. It is calcium that gave it to chlorine. That 2 chlorine has, it is calcium that gave it to it. So it's going to be Ca, alright. And chlorine gave it to 1, and Cl, alright, 2. It is calcium, and you know that was CaCl2 because 1 is nothing. Class, are you following me? Because I want you guys to be familiar with all this. When you are answering questions, you should be professional. I know we are learning, but we get to know all this. Class, do you understand what I just said? All this thing I'm explaining, do you guys understand? You know, I'll give you guys some questions very soon. No? I'm just trying to play, give you guys some questions to play with. We're not talking about physical change right now, all right? I'm just asking, do you guys understand what I'm saying? Do you guys understand? Because I want you guys to basically, so on this, what becomes the product of your charges? It is going to be Ca2 plus what Cl. We need all of this knowledge, eh? So I want you guys to at least to some extent know what is happening. Not me just say, you have to actually need to know how to do all of these things yourself. Alright? Because how it will form. Let me wipe again and give you guys another. And this time around you work it out, alright? You work it out. So I'm wipe the board. You work it out on the whiteboard. This one is for you guys. AlCl3. This is 3 aluminum chloride. Class, what's the charge for each of them? Aluminum should be what charge? What charge? Tell me the charge that should be inside. Tell me, simple. Aluminum what charge? Chlorine what charge? Class, tell me now. Don't from my hand. Told you already how compounds are formed. All these kind of compounds, and we call them ionic compounds. Ionic. I'll teach you on chemical bonding. Ionic compounds, covalent, there are different things. For ionic compounds, it is metals and non-metals. Those compounds they are contains elements that are positively charged and negatively charged. All these ones are ionic because you can see some parts positive, some parts negative. They are ionic. Ionic or electrovalent. We'll learn it properly in chemical bonding. But before they tell me the charge for aluminum and tell me the charge for chlorine. So exactly. Aluminum should what? Plus 3 and chlorine should what? -1. Do you understand? Very easy. Just said. Even if I go deep, you'll be able to get this thing. It's not hard. Alright. Can I wipe? I believe you guys are following me. Can I wipe? Because we need all of this knowledge, Joe. We need this knowledge. We need a lot here. Alright, that is for that, guys. That is for that. So pay attention. So moving further, guys. Let us now, because in this aspect, you'll be expected to now molten sodium chloride. You can ask you, what are the charges present in molten sodium chloride? What are the charges? It's very easy. Look at. See, in molten sodium chloride, in sodium chloride without water, there is Na plus for sure, and also there is Cl minus for sure. Class, do you understand what I just said? In molten, because I know that NaCl is plus they have that. That's why I just did this. Do you understand? So if they ask you also, what are the charges present in this sodium chloride solution? Oh, class, listen. Normally, there is sodium chloride first, which is what? There is Na plus, it's plus 1 minus 1, you understand? So there's Na plus 1, there is also what class? There is Cl minus 1. But now there is water. Let us work it out, guys. Water now, don't form my hand the water. There is what becomes hydrogen, alright, and what becomes the charge for hydrogen? And what becomes the charge for what? Oxygen. Because these are the guys, when the 2 is with the other, it means that it's that guy that gave to it. So guys, I know that I told you the one that's standing first should be positive. The one that's standing next, second should be negative. That's tell me the charge. Don't for my hand. Oh my God, you guys are smart. You guys are so smart. I'm proud of you guys. Alright, you guys are so smart. But actually, you guys are correct. You are correct. But actually, this is how water is broken. I wanted you guys to just do it like this, so are totally correct. But this is how water is broken normally in electrolysis. Make una listen. I taught you in acid and salt. Water is broken in this way. H plus plus OH minus. H plus 1 plus what? OH minus 1. Class, this is how water is broken, no, not this pattern. You are correct in other aspects in chemistry. But in this electrolysis you want to learn, this is how water is dissociated. This is how water is dissociated, that's the word. This is how water is what dissociated or broken down. Class, are you there? So basically, sodium chloride solution will be the sodium and chloride ion present, and also H plus 1 and also OH minus 1. Class, are you there? So if they ask you what are the ions present in basically in a compound solution, definitely these two gas must be present and the compound itself, but the compound doesn't change. But for water is broken down as H plus and OH minus. You guys there? All these are very, very important. All right, they're all easy. Class, what I just said, is it clear? What I just said, does it make sense? Does it make sense to you? Because we are coming. Very good. All right. Class, let's work out this one. Copper 2 sulfate solution. All right. I want to wipe this at least. I want to wipe this. You understand how that one was gotten now? Class, I want to wipe this. Pay attention, though. Copper 2 sulfate solution. These are the components. All right. Class, listen. Copper 2 sulfate. Class is very easy. Look at it. Copper 2 sulfate. Simple. Copper 2 sulfate. This is copper 2 sulfate, guys. Is this not copper 2 sulfate? Even, let me tell you, in this kind of commodity, it is much more easier. Copper 2, wow. It is copper 2, that means it is Cu2 plus. You know from, see now, you don't want to use this one to get it. Class, listen. For compounds that, let me give you the summary. For compounds that are, they just give you the name without adding any number most times, you have to be careful. Copper. That's why as a student, you should know that copper is 2 plus. Anywhere, every day, copper is what 2 plus. So that's why it's like this. And I saw sulfate. Sulfate is SO42 minus. You must know. Sulfate is what SO42 minus. And now, it is a solution form. Class, it is H plus and what? Plus 1 specifically and what? OH minus 1. Class, are you there? While for molten is simply just copper 2 and what? SO4 2 minus. Class, are you there? Class, note all these. Don't worry, I'll walk. See, don't worry. All these are easy. Just relax. Copper is Cu2 plus all the day, and sulfate is always like this. That's what they expect from you. As a student, you should not forget that sulfate is SO4 2 minus. Never forget. Don't forget is a problem. Are you guys following me? So these are the components of these guys. So I'm going to give us more so as to master. Alright, this one I'll give now is this. It is molten potassium hydroxide. I taught you guys also in acid base and salt. And hydroxide is OH. This thing that is OH is called hydroxide ion. And it's potassium hydroxide. Potassium is not K. Class, potassium is K. And hydroxide is actually KOH. Class, yes, it is. It is as molten, just that guy itself. But if it is, what do you call it now? Potassium hydroxide solution. What should that be? You know what it should be now? It should be potassium hydroxide itself and what? Water itself. You understand? Potassium hydroxide and what? Water. You get what's happening? All these things are very, very easy and not difficult at all. Alright, so I want you guys to finish everything for me. What should be the component? They are easy. OH goes together. OH goes together. And I told you it is plus and minus because this kind of compounds are ionic. So tell me, what should be the charges? Class, up for my hand. Don't fall my hand. Don't fall my hand, all right? I'm waiting for the charges present, the ions, we call them ions present in the potassium hydroxide and, what do you call it now? Potassium, molten potassium hydroxide and also potassium hydroxide solution. And also potassium hydroxide solution. Let me see how smart you guys are, all right? definitely now KOH. There's no number. That means one from this gate to the other one of gate. That's why it's KOH. You understand? So it will be K plus 1 and OH minus 1. And if it's the other one with solution, it is K plus 1, OH minus 1, H plus 1, and OH minus 1. But there's something I'll tell you guys. I'll tell you guys something very important. Alright, so you guys pay attention. And let me see how smart you guys are. There's something I want to tell you guys. And listen. Class, tell me now. I'm waiting. You guys should tell me you're wasting time. Oh, just one person? See, you should basically tell me, do it, write it well, don't rush, write it well so I'll know your answer. Okay, let me do this one for us. Ever listen. Multi-potassium hydroxide. Multi is just, it's KOH now. So it actually is K plus 1 and combined with OH minus 1 for sure. And yes, now this multi just itself, right? But now for this potassium hydroxide solution, it is not K plus 1, comma, OH minus 1. Hope you know how this are gotten now. Now it's going to be H plus 1. Class, listen, let me see how smart you guys are. And OH minus 1. Class, don't do this. Don't do this. Are you not seeing now that you have identical? They are the same. You just remove one. You what? Remove one. I repeat again. Whenever you want to dissociate and you see that the one is identical, alright, like you have one that is 2, you remove one because now potassium hydroxide has OH in it. Water also has OH, so you remove one of them. You understand? As you understand what I just said, please you remove what one. You remove what one. Alright? Even show the other one is just as if we are trying to repeat ourselves. Don't worry. When we start working questions, all this will make sense very soon. You can see the ions present now. You understand what I'm saying, guys? Well, I'm going to give us one more, which is what? H2SO4. It's an acid. H2SO4 solution, not from my hand. Class, H2SO4 solution. The H2SO4. I believe you should know what actually came together to form this guy. Hydrogen and SO4, which is sulfate. Class, tell me. So what to some extent will be our charges? I know I've explained this, you can do it. I will not say this. You tell me the answer. Let me see how smart you guys are. I will not say this one, and you will ensure you tell me. So do that for the H. Very good. You guys are doing so well. I'm proud of you guys. All right, but for the hydrogen, tetrahydrogen will be 6. All right, tell me what should be the component. All right, and there's solution at the end, so you should be very careful, guys. You should be very careful so we can start working and solving questions. All right. So I'm working so we can start solving questions. I'm waiting, guys. I'm waiting. Do it well now. Tell me the ions present. I'm waiting. You guys are not answering. What is wrong? I'm waiting, guys. I'm waiting. Nobody has answered. What's wrong? Is it so hard? Let's look at it. No. H. Exactly. You are not done. It's a solution, precious is a solution, so finish it. You saw solution, so there must be water, alright? But you should be careful, alright? So tell me, guys, alright? In H2SO4, look at it now, H2SO4, I know that there will be H plus and SO4 because it is like, look at guys, it is H2SO4. And 1, and this one signifies nothing because when 1 times everything is still everything. Like 1 times 4 is 4, 1 times 1 for sulfur, but this sulfur is 1, so it's still 1. So everything becomes H2SO4. We just remove the 1 plus nothing. So you can see initially the ions that came together, which are H plus 1 and SO4. So there should be H plus 1 and what? SO4 2 minus, and also H plus 1 and also OH minus, but there is a solution at the end. But I told you, whenever you see ions that are identical, you will cancel 1. You understand? So this one just H plus 1 SO4 2 minus and this one.
You understand what is happening, guys? They are all very, 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 very easy, because I know why I'm stressing on all these. They are important in this aspect, so you guys should pay attention. Practice makes perfect. For this compounds I am basically talking about, they will help you a lot. All right, so you guys should pay attention. All right, you guys should pay attention. Guys, is that clear? All right, Treasure, you can see your mistake. Most of us made a mistake by basically writing all of the hydrogen ion. I told you guys already. All right, I told you guys already. You don't write identical ions. You get, right? You don't write what identical ions, so we can move further to learn other necessary information on this aspect, so we can start solving questions, because they're all very easy. They're all very, very easy. Exactly. You can see how easy these stuffs are. They are not difficult at all. But I know why, at least for some extent, you get to know the difference between something that is a solution and something that is molten. But we need all of this knowledge to answer questions. Guys, you can do a video for me and send to me my DM, alright, as I teach, so at least. Alright? So that is for that. So let's get straight into question 1 on mechanism of electrolysis. Alright? Question 1 on mechanism of electrolysis. Exactly, Treasure, good one. Alright, question 1 on mechanism of electrolysis. So I'll be wiping all of this so we can get into the first question. Alright. Guys, pay attention, no, pay attention, pay attention. Listen up. All right, so let us move further. Class, listen up. So let us solve question 1 on this aspect, and it says, question 1 says, describe the mechanism of electrolysis of molten sodium chloride and states the product formed at the anode and cathode respectively. Simple. Question 1. It says describe, explain, because this is where objective questions come from. Describe the mechanism. Describe the mechanism of what? Electrolysis. Of electrolysis of molten, class listen, of molten sodium chloride and states what is formed at the state what is formed at the anode and cathode, all right, respectively, and cathode respectively. They are all easy. Respectively, class. How do we solve this simple question? Guys, listen up. You can screenshot here or you can video here, all right? How does this work? Easy. They said describe mechanism of electrolysis of a compound, and that compound was a molten form. Listen. What is the first step in mechanism of electrolysis? Ionization. In ionization, that's your compound in the question, you break it into ions like those ones we talked about. You know, ions can be of two types. We have those that are positive, we call them cations. Those that are negative, we saw it just now, we call them anions.
So me saw molten sodium chloride, I know that sodium chloride NaCl. I know that if I don't break this guy into ion, this is what I'll get. I'll definitely get Na+1. Hope you know. And then I'll definitely get a plus Cl-1. The reason I wrote plus just because it's a reaction, you understand? I can also use comma to also separate, just know that these are the two ions present in this. So we've done step 1, which is what ionization. It is very easy. So what is the next step? Migration. Then I'll teach you how it works. What is the next step? Migration. Then I'll teach you how it works. Alright, they're all easy. What is the next step? Migration. Then I'll teach you how it works. Migration, like you are traveling from a place to another, you are migrating, you are leaving Nigeria to another country. That's migration. Alright, so how does it work? How does it work? You guys pay attention. I'm going to teach you guys how it works. Ionization basically just basically forming the ions, breaking, dissociating the compound to form ions. That's what that means. On this axis, no much talks. No much talks. Here. Guys, in migration, these ions you have formed are migrating. They are migrating to where? They are migrating to America, right? No, they are not migrating to America. They are migrating to the terminals, which are anodes and cathodes. Anodes and cathodes. So in migration, we have two terminals, which are anodes and what? Cathodes. Class, which cell are we talking about here? We are discussing about electrolytic cell. And in an electrolytic cell, which one is positive anode, which one is negative cathode? You understand? So, according to a man in science called Charles D. Augustus Coulomb, he said that like charge repair, man repair, woman repair, man attracts. Do you understand? So plus minus attracts. Are you there? So what happens? You look at your charges, your ions, and migrate them based on the charges of your terminals. So you are positive. Where will you go to? You will simply go to the negative pole, the negative guy, the negative side. You are negative. You simply go to the positive guy. So in this case, which ion will be migrated at the cathode? It is positive, it is negative. Then sodium ion will come. Why? Because sodium ion is basically what? Positive. What about anode? Which will come? Chloride ion will come. Why? Because chloride ion is what? Negative. Because anode is what? Positive. Class, do you understand how migration works? Alright. How migration works, you can see how easy it is. So let us work on discharge. Alright. Let us work on discharge. Let us work on discharge. They are all easy. In discharge, class, listen. In discharge, the ions that were migrated to each terminal will now be discharged. Do you understand? At that terminal. Just listen. What was the ion? Let's start with the cathode. The ion that was migrated to the cathode, what's the name of the ion? It is sodium ion. Then I'll notice, it is sodium that migrated, Na+1. Then, let me just tell you. So, in your exam question, they ask you, say what is formed at the anode. So, what was formed at the anode? Is it not chloride ion that was formed? What was formed at the cathode? Is it not sodium ion that was formed? Yes. But that's correct. But you have to know how to write the reactions for during the discharge. There are reactions to write. They are all easy, class. They are all easy. To write this reaction is simply based. It is simply based on some concept. Alright? It is simply based on some concept. Guys, listen. What did I tell you? That anode undergo and also cathode undergo. Class, have you forgotten? Anode, what do you undergo? You undergo reduction. Class, what did I just say? Anode, what do you undergo? You undergo reduction. Sorry, cathode, what do you undergo now? Oh my God, yeah. Cathode, what do you undergo? I undergo reduction. Cryo. Have you forgotten? Listen, no. Cathode undergo reduction. Anode undergo what? Oxidation. So basically, anode will now undergo what? And what was, walking to the anode, it is chloride ion, Cl-1, and you undergo what? Oxidation. So let us learn what is happening. Alright, let us learn what will happen. There are reactions performed, and they are all easy. Now, before moving for that, let me teach you guys something. At least, let me just bring redox into this picture. Now, listen, everybody. Listen. Let me divide these two terms, reduction and oxidation, based on electron. That's what we need. Listen, there is a definition to note here. And to know that definition, remember this thing, oil rig. What did I say? Oil rig. Oxidation, O, is loss, L, of electron, while reduction, G, is G. Reduction, R, is G of electron. What's G? Gain of electron. In oxidation, electron is lost. In reduction, electron is gained. What's the symbol for this electron? Electron is symbolized as E minus. What did I say? Electron is symbolized as what? E minus or E minus 1. Because that minus just tells us minus 1. Class, listen. Listen. All this is not hard. I know what I'm talking about. At least, to some extent, I want you guys to know how to write reactions on your own. Alright? This reaction is happening. Alright? This one that is, if you want to write it on the cathode, it has a name. Listen. So sodium will undergo reduction in this case for sure. Sodium will undergo what? Reduction, because it was an identical what the cathode. So it behaved the way cathode behaved. So it will undergo what? Reduction. And what is reduction based on electron? It is gain of electron. So it simply tells me that this sodium will gain electron. Will gain. And when you gain in a reaction, reaction has two sides. We have the reactant and product. So if what is reacting together that will form a product. Are you there? And what does it mean for something to gain? It simply means that, and when you lose, it goes to your product. That's what it means. When I lose something, it goes to my product. When I get something, it stays with me, my reactant. So this is what happened. This is the sodium, Na+1, everybody. Is this not the sodium? And it is what? Undergoing reduction, which is what? Gain of electron. Which is what class? Gain of what? Electron. And this electron is E minus. So I am gaining electron, E minus. This electron, I am gaining it. So it stays with me. If I was losing it, it will go to my product. That is the picture. So when this happens, class, you guys should pay attention now. I believe you understand what's happening. Alright? I believe you're understanding what is happening. Alright? Listen and listen well. Alright? They're all easy. They're all easy. Alright? Just hold on. Just hold on. Hold on, guys. Hold on, so I teach you what's happening. They're all easy. Just wait, let me tell you guys something. Just hold on. We want you guys to see all these things so clear. Alright, that's why I'm taking my time to explain all this. You must see so clear. That's the most important. Alright, that's the most important thing here. Alright, so guys, pay attention. So, remember I told you that electron is what? Negatively charged. And when you're it's E minus, so particularly it's just E minus 1. You understand now? You understand? So this one, now this electron is E minus 1. You understand? So what is happening? I told you already, when you are gaining electron, it comes to you. So it's very easy. Let us now use because definitely these two guys are combining. So if the charge will now basically calculate to know the kind of sodium we're going to get. Alright, if it's the charge of sodium, that's what I mean. We know the charge of sodium we're going to get. Class, listen, I believe you're aware that this is +1 and this is -1. So how does it work? Just pay attention. Alright, let's work it here. +1 in a bracket, which are seeing here, this +1, plus, guys, plus plus minus 1. What's this? When plus 1 plus minus 1, what is that? Simple now. You know, plus times minus is minus. So 1 plus 1 minus that one is 0. Hope you guys are aware. So the sodium we are going to form is Na plus with the charge to be 0. Are you there? So when the charge is 0, simply that this sodium is neutral. But when I have 0 charge, I am neutral. This don't matter. The anything where for 0 is 1. No. You understand? So basically, that is for that. So this sodium is neutral. This sodium is electrically neutral. There is no charge. So this is the correct reaction for the cathode. They call it, so basically at the cathode, what was formed? Sodium, metallic sodium, because this sodium is a metal. I told you guys already. This sodium is a metal because metallic what? Sodium. So what happened? The sodium gained, the ionic sodium gained electron. The ionic sodium, because one other is an ion. So the ionic sodium gained electron to become what? A metallic sodium. Are you guys there? To become what? A metallic what? Sodium. To become what? A metallic what? Sodium. That is for that. So let's get into, so this reaction here, they call it cathodic reaction. What I say is called what? A cathodic reaction. A cathodic reaction. Because the reaction occurred in the cathode, cathodic. Let's work on this, very easy. This chloride is undergoing oxidation. And what is oxidation? Oxidation is simply loss of electron. Electron is lost. And class, listen and listen well. Whenever electron is lost, I told you, it goes to your product. I don't need it. So this guy is undergoing what? Oxidation. So and the Cl minus at first. So it will undergo what now? Because there is loss. So the electron was lost. And I told you when electron is lost, it goes to your product. I don't need it. You understand? So electron here was lost. So how do you now balance it to know the kind of guy we are going to form? Pay attention, no. Pay attention, guy. Let me tell you what is happening. Because at the end of everything, we want to ensure that what the charge, look at what we are doing. We want to ensure that the charge in our left equals the charge in our right. Do you understand? The charge in our left equals the charge in our right. If you check, the charge in our left was 0. Because when this guy plus this guy 0, and the charge in our right, what's the charge here? 0 now. You get. So that's the sense one will use here. The charge in our left will equal the charge in our right. So what should happen? Remember, this guy is going like this. You understand? This guy is like this. Do you understand? Yes now. Yes now. So basically, to ensure that the charge are equal, there is a gas, and also to balance the reaction. Definitely chlorine appeared here. So what kind of chlorine will be here? It's very easy. It's just Cl2. What did I just say? It's just this one like Cl2. Because chlorine doesn't just exist like this. Chlorine doesn't exist as Cl like this. It exists as a gas. And when you exist as a gas, you are Cl2. Class, relax, hold on. I repeat, when you are existing as a gas, you are what? Cl2. When you are existing as a gas, you are Cl2. Then I'll show you guys what is happening. Alright, when you are existing as a gas, you are what? Cl2. Alright, we must ensure that whatever we are doing is, we must ensure that everything is balanced, the reaction is balanced. Because if we check the cathodic reaction, how many, let's check our elements first before charges. How many sodium do we have in our left? We have 1 sodium. How many do we have in our right? 1, right. Sodium is balanced. Let's check our charge. What was the total charge in our left? The total charge is 0 now. Yes, now. What was the total charge in our right? It's 0. There's nothing here. So we still use that same picture to balance this one. What's the total? First of all, how many chlorine? First of all, check the atoms, the elements. How many chlorine do you have in our left? Leave chart. 1 chlorine. How many chlorine do you have in our right? 2 chlorine. So it's not balanced. So for me to balance, I have to basically put 2 in the front. I've taught you guys now, to balance a chemical reaction, you simply add numbers at the front. You don't add numbers inside. You add numbers at the front, which you have done. So we'll balance the chlorine. Alright, but doing that, it will water the charge. Because this number is affecting everything, both chlorine and the charge. So this time around, the charge is 2 times minus 1. That is minus 2. What did I say? 2 times, we must ensure our charge. I cannot stop here. Because if I just say 2 times minus 1, which is, yes, 2 times minus 1. 2 times minus 1 is minus 2. So and this charge here is just minus 1. So to balance the charge, we simply still add 2 in the front of the electron. Do you understand? Yes now, so 2 times minus 1 minus 2. So you can see that at the left and the right, the charges are balanced. At the left and the right, the elements are balanced, guys. Are you there? So this now we call it anodic. Anodic what? Reaction. Are you there? So if you ask what was actually formed in the anode, what gas? Chlorine gas. It is not chloride, I don't know, that was formed. What gas? Chlorine gas was formed at where the anode, which what was formed at the cathode? Metallic sodium or sodium metal was formed at the anode. Class, this thing is easy. This is mechanism of electrolysis. Class, is this understood? So I give you guys your own question. Let me know. You must learn how to write reactions. Let me know, guys. Is this understood? So I give you guys your own question. Let me know, guys. All this explained, is it understood? So I give you guys your own question. First, before we now proceed higher, let me know in the comments, is this understood? They are all very, very easy. You can see how we have tackled all of this. Alright, let me know if it's understood so I can move further. Alright, let me know if it's understood so I can move further. Alright, very good, very good, very good, very good, guys. So I'm waiting for other person's response. Others, I'm waiting for your response. Or are you writing? Very good. Very good. Very good, very good. So you know what you do for me, guys? Just hold on, give me some like 1 minute. All right. All right. Chibo say ask a question. I want to go get water so I can drink and have energy. So ask a question before I go. So you just give me some few minutes. You will not be able to hear me, like, I'll leave the room I am now to go get water. So Chibo say ask a question before I go get water. All right. So I can give you guys your own and then you guys will work it exactly the way I taught you guys. They are all easy. These things are cheap. They're not hard. So I want you guys to basically, if you have a question, ask a question, so I can basically, go get water and drink water before I come back. Chibos, I'm waiting for your question. I'm waiting for your question. No, don't waste time. We have a lot of things to do on this topic. All right, we have a lot of things to learn, so don't waste time, please. Oh, you don't want to ask question again? Just let us know now. I want to leave this place now and get water and come back. Guys, can you hear me? Guys, can you hear me? Yeah, I'm waiting. Ask a question, Chigozi. I have asked the question. Okay, in Electrolytic of Brian. Oh, hold on now. We are coming. Just relax, Relax. Hold on, we are coming. For your question, just relax. We are coming, Not too clear. Where exactly is not clear to you, Elizabeth? Just let me know. Just let me know exactly where it's not clear, so I can, because this one is very crucial. You have to know it. Because before I move further, everybody should have to know all this. So please let me know now. Where is the problem? All right. I told you guys already. You must know what is happening in the cathode, and what is happening is reduction, and what is happening in the anode is oxidation, right? So basically, migration is basically you just moving the ions you have formed to their terminals. And I told you the ones that are positive always goes to the terminal that is negative, while the ions that are negative goes to the terminals that are positive. So you that asked this question, did you get what I just said? Did you get what I just said? Let me know. Did you get what I just said? You got all right. Others ask your question if I move. I want to get water. I will soon leave the room. So you not hear me. It doesn't mean that network is bad, right? Just relax. So you guys should not panic. So can I go now? Can I go now so get water? All right, I'm leaving now, so I can get water. I'm coming. Just give me some time. I'm coming. It won't take like maybe 2 minutes. I'm back. Fine, I'll give you guys your own and see. Chiboy, I'm going to answer a question by solving a question on it. Oil rig, alright, oil rig. Oxidation is loss of electron. Reduction is gain of electron. Reduction is gain. Oxidation is loss. What are you losing? What are you gaining? Electron. Chiboy, relax. I'll work on your question. Alright, I'll work on your question. Cathodic anodic reaction, basically, they are like the reactions occurring at the anode. They call them anodic reactions. Reaction occurring at the cathodic reaction. You understand? That's what's happening. Do you get? So I'm coming. Just give me some time. Alright guys, I am back. Alright guys, I'm back. Alright. I'm coming, I'll give you guys your own first of all to practice with. So I'll give you guys your own questions to practice with. Alright. I believe you guys are ready for your own. It's exactly the way I just asked this. That's how I'm going to give you guys. I'm not changing anything. But after you solve this, I know that everybody at least to some extent will know this. I will not increase it. Alright, so I'm coming. Hold on. Hold on, guys. Alright. I'm coming. Okay. All right. I think I've seen one question I want us to work on, and it is on describing the electrolysis of molten lead bromide. Class, it's simple though. It is a very easy one, so I don't want you guys to feel it. It's simple. All right, describe the electrolysis of molten lead. Your own is lead bromide, Pb and Br2. Class, I told you, when you see something like this, you should know the charges. Take your time, work on the ionization. Quickly do this one. All right, tell me, like first, you need is possible for you to write, type it. Just do it. It's not hard. All right, so I want you guys to work on this before I move further. I'll give you guys some time so we can move further and teach you guys other ways questions can come on this aspect. So we can move further. I'm waiting. Hope you guys got the question. First of all, did you get the question? I'm waiting. I want you guys to get the answer correctly.
I want you guys to get the answer correctly. Alright, so I'm trying to form that question so as to give to you guys based on what Jam have asked so far. Alright. Alright. No, Precious, take your time. That's for is that the ionization? Precious, remember that I told you all these compounds are ionic. So basically the first one most times is the metal. So you should tell me the chart, don't just tell me minus, alright? Take your time, guys. I'm waiting. Nobody has gotten it yet. Nobody has gotten it. I'm waiting, guys. Oh my god, I'm still waiting. Guys, I'm still waiting. It's taking time. I know you have to take your time. Don't rush. I'm taking step by step. All right. Guys, nobody yet. What's happening? No. For you, Lanrio, it is lead should be positive now. I told you already. Lead should be is a metal, so it's positively charged. So it should be Pb2 plus. All right. Should be Pb2 plus, guys. You guys, everybody just telling me just very good. Rahab, very good. All right. Oh, very good. All right. Is that your final answer, Precious? Others confirm? Now I told you now you should form a reaction for me. Don't just do that. Form the cathodic and anodic reaction based on what I've taught you guys. It's not hard. All right. It's not hard at all. So you guys, I want you guys to work it out. Guys, I'm waiting. I want to leave you to go to another question. All right. Alright, remember leaving so you can work it out and provide the answer in my DM to confirm if you're correct. Alright. But before then, also provide the answer here. Alright, guys. Alright. So I want you guys to work on it and you provide the answer. Alright, somebody did something nice. Wow. You guys are doing well. I love what you guys are doing. Precious is trying. Alright, Precious is trying. All right. So I'm happy about you guys can basically, confirm by give me the question on my DM, so I'll tell you if I'm correct or not. All right. So without wasting time, I'm about wiping the questions. I can give you guys another one that I want you guys to see how questions works on this aspect. All right. So I've changed the compound and I want to rearrange it. So I'll tell you guys something very important. I'm going to tell you guys something very important. Now, electrolysis of dilute sodium chloride solution. Class, listen and listen well. This question, you have to be smart. First of all, let me wipe the board. Everybody listen. Leave what you are doing and listen. Leave whatever you are doing right now and listen, everybody. What is really happening? You can see that the compound will change the format in the sense now that the compound here is in the form of a solution, and specifically it is diluted. That means we've diluted the compound. The compound is not concentrated. The compound is not molten. It's diluted. That means you have a lot of water in the compound. Class, listen. First of all, we have sodium chloride in that compound, and also we have water in that compound, right? So when you break sodium chloride, you're going to get Na plus 1 and what? Cl minus 1. And when you break this one, what are you going to get? H plus 1 and also OH minus 1. Class, pay attention. If you observe, you have formed different ions. For the ones that are positive, you form 2 ions. For the ones that are negative, you also formed 2 ions. Then they will be migrated. Some will migrate to the anode, while some will migrate to the cathode. And you already aware that anode is positive, whereby cathode is what? Negative. So which set of ions will migrate to the anode? This is your question. Now, because you see now you have 2 ions, 2 set of ions, you move them to the anode. Since anode is positive, then we attract negative. So the ions that come to the anode, they are chloride ion and also OH minus 1, which is hydroxide ion. Chloride and hydroxide ion will basically go to the anode because they are negatively charged. While for the cathode, these guys will go, which is what? Sodium ion and what? H plus ion. Class, I beg you, God, note all these. They are all very easy. Then you can see what's happening. Then, class, in this case, there is a competition. Yes, because initially, when that compound wasn't
in a solution, it's just molting itself, no competition. When we went to the discharge at the anode, you knew what happened. Let us have the cathode here, and also at the anode, you knew what happened. For those that initial one that we don't have any competition, we just moved what was migrated to the anode and cathode and discharged them. But due to the fact that we cannot move two sets of ions, like in this case of anode, I cannot discharge both of them. I will only discharge one. So how do you now know the one that will be discharged? That is what we call preferential discharge of ions in what electrolysis. There are factors that affect preferential discharge of ions in electrolysis, and we have some of them. Let us talk about the first. Number one, write it in your note. It is called position of the ion. I repeat, position of, they are all ions. Why? Because an ion is a charged atom. So number one factor that, because now you can see now that is a solution. So now what will happen is that let us learn the preferential discharge of ion, and this occurs in various factors. The first factor that will determine the ion that will be discharged is what we call position of the ion in the electrochemical series. And I'm going to list out all these elements that forms the electrochemical series for us so we get what is happening. So I'm going to basically work on that in this part of the board. I'll make it, so I can write everything. Guys, I beg you, listen and listen well. What we have two sets of electrochemical series. We have electrochemical series for metals and electrochemical series for non-metals. In summary, we have electrochemical series for elements that are positively charged, which are metals, and also have electrochemical series for elements that are negatively charged, which are non-metals, guys. Pay attention. Pay attention. The first one is potassium, K+1. Potassium, sodium, Na+1. Calcium, Ca+1. There is some potassium, sodium, calcium, magnesium. Alright, there is some calcium, magnesium, Mg+1. Calcium, magnesium, potassium, sodium, calcium, magnesium, aluminium. Alright, aluminium, Al3+, zinc, Zn2+, iron, Fe2+ or Fe3+, iron, tin, Sn2+, lead, Pb2+, hydrogen, Ha+1. Class, listen. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, Sn2+, lead, Pb2+, hydrogen, H+, 1, copper, Cu2+, mercury, Hg+2, iron, lead, hydrogen, copper, mercury, silver. Silver is Ag+1, and gold, Au+1. Another element, platinum. Platinum is also +1. Yeah, roughly. Alright. So guys, I believe you can see the list of these guys. I want you guys to pay attention. Before I move further, can you guys see the list from beginning to the end? Please let me know. Can you guys see the list from the beginning to the end? Can you guys see the list of these elements and tell me their charges? Are they positively charged or negatively charged, guys? Let me know in the comments. Very good. Oh my God. What's your name? Your name starts with CTW. What's your name? Let me know. You did well. You did well. You did well. So what's your name? So we can move further. Class, hope you guys are following me. Oh, yeah, because due to the fact that platinum exists in various oxidation states. Platinum can exist in +2, +1, as the case may be, even +4. All right. So let's just say in this case, the platinum is existing as +2, but it doesn't really matter right now. Class, do you understand what is happening? Please let me know now. All these are the electrochemical series for metals. Why? Because they are all positively charged. So I'm going to tell you guys something about the board, so I can write the electrochemical series for non-metals. The electrochemical series for those ones that are negatively charged. The electrochemical series for those ones that are what? Negatively charged. Class, listen, oh. And there's an acronym which is Felix. Show, know, consign, breaking, arrange, heart. So what are the guys? Felix is fluoride ion, F-1. Show is SO42 minus that sulfate radical. No is NO4, NO3 minus rather. Consign is Cl minus 1. Breaking is Br minus 1. Arrange is I minus 1. Yeah. And heart is OH minus 1, guys. Alright, just learn it the way you are saying it. Learn it the way you are saying it. Guys, can you do this what I've said? Please let me know in the comment. Very good. AK Godfrey, you are doing so well. Ogechiku, you are doing so well. Guys, are you not seeing the acronym for the non-metals? No, for you to be non-metal, you are negatively charged. Alright? So let me tell you guys something what is happening. There is a song that I was singing on this aspect back then in secondary school. Alright? Alright? Just listen. Just listen. Just listen. Just listen. Yeah, it's so tiny. Please try to see it, please. But is it clear? I know where I have to write, but everything so everything will contain the board. All right, class. Can you see what I've written? Please just look at it. Guys, look at it too. Guys, can you guys see the board? You guys should answer me now. You guys aren't saying anything. You guys should be answering me on time. So, the way these elements are, they are arranged due to the fact that as we go down them, down, as we go down like this, down, they are decreasing in their reactivity. I repeat, they are what? Decreasing in their what? Reactivity. They are decreasing in their reactivity. Note that. They are decreasing in their reactivity. Alright, know what I just said? They are decreasing in their reactivity. Oh, is that network? Do you mean do you mean the board in general or what I've written, that part? So you tell me. Class, you guys should tell me now. Oh my God, I'm so tired right now. Alright. So, the reason I have to tell you guys this, let me tell you guys, listen. Whenever class, you see dilute form of a compound, they just say dilute, and at the end they call it solution. To be able to know exactly, because definitely when you say solution, you are going to form two sets of ions. What I say, you are going to form two sets of ions. You get a positive ion and negative. Like, you are going to form two sets of ions in the terminals. So, which one will be preferentially discharged? Class, listen. Remember, you are aware that in cathode, it undergoes reduction, where anode undergo what? Oxidation. Oh, am I right? Cryo, yeah, I'm right. Cryo. So now listen. Between chloride and this, which one will be preferentially discharged? Which one will discharge to your anode properly? Alright? And this, which one will discharge? Listen. The one that is lower in the series will be preferentially discharged, guys. The one that is lower will be preferentially discharged. I repeat, the one that is lower will be preferentially discharged. Let's check. Between these two guys, which one is lower? It is OH, right? It's lower. You can see this guy is lower. So OH will be preferentially discharged. Will be preferentially, or we just say will be discharged. All right, will be what? Discharged. Oh, sorry about that, guys. Just try to look at it because I want everything to be on the board. That's why I'm doing all this. All right, will be what? Discharged, guys. Preferential discharge. All right, preferentially discharged will be preferentially discharged. All right, discharged. You get. What about this guy? Between these two guys, class, between Na plus and H plus, tell me which one will be preferentially discharged? Tell me. I told you one that is lower. Tell me, class. Oh, H plus will be preferentially discharged now. I not seeing H plus here. Sorry about the way the writing is fast. Sorry about that, but just try to look at it. H plus is there, Na is up here. So H plus will be preferentially what? Will be preferentially discharged. Are you guys following me? So you can form your reaction properly. So what is the reaction? So since this is a reduction. And what occurs the reduction, guys? What occurs the reduction? It is what? Gain of electron. So that guy will undergo gain of electron. Alright? If we undergo gain of electron, is it gain or loss? Tell me. Oh my god, what am I even doing? Oh, you guys didn't even tell me. You are just allowing me to write. Class, so cathode. Cathode is negative now. You guys said. Look at cathode. This guy definitely it appeared in the anode. So here should be anode, not cathode. Alright? Anode. And this is anode. Anode undergoes what? Oxidation. So let's not get it wrong. Whereby this one, cathode, it undergoes what? Reduction. Because look at it, a cathode, anode. You understand? Reduction. Do you understand? So that is for that. So you now form the reaction and I'll teach you how that works. Class, is it clear? Look at the board well now. So you guys don't make mistake. Look at the board though. What I just did, is it clear? What I've explained so far, is it clear? Let me know. It's clear, right? Exactly. Alright, so what do we do next? Here, let's form our reaction. You know, in anode, this OH, right? Since it's undergoing oxidation, what will be happening? Is it gain or loss of electron? Loss now. It will lose electron, and the electron will be this guy. Alright? The electron of that guy will lose. Well, that to know as a student what exactly to form. Let me just tell you. Whenever OH is undergoing oxidation, hydroxide ion is undergoing oxidation, it forms water and oxygen gas. This is a very simple thing. Class, whenever this guy is undergoing oxidation, it forms water and oxygen gas. And as a student, you should balance your reaction. What did I just say? Class, balance this reaction for me. Because this is still, listen now, I'm just telling you now that if you don't know, learn from today. Whenever OH minus hydroxide ion is to undergo what? Oxidation, you form water and oxygen gas. So let's balance. And definitely, electrons will be lost, which is me showing that right now. So what happens? First of all, we must ensure that our atoms are correct, balanced, and our charges. How many oxygen do we have on our left? We have just one oxygen. How many oxygen do we have on our right? We have 3. 1 plus 2, 3. So what do we do? I think it's best for me to put 2 in the front here. When I do that, oxygen will not be 2 here, and oxygen will be 2. That's 4. So it's best I put 4 in the front here. So oxygen will not be 4 here. And this first affecting hydrogen, hydrogen will not be 4 here. So let's check hydrogen. 2 times 2, 2 times 2, 2 times 2, 4. 4. Hydrogen is 4. Let's check our charge because 4 is affecting charge. So here at the left, the charge is minus 4. Yes, now minus 4, minus 4, minus 4. What becomes the charge here? Definitely 4 will be in front of electron. And electron here will minus 4. So this is the correct reaction. Alright? You can see what was liberated. You got the oxygen gas and water. Or oxygen gas and water was basically giving off. You understand? So that's for that, guys. That is for that. So let's work for the cathode. Alright? It is H plus. So H plus because it's cathode gain of electron reduction. So the gain electron. So what do we have? We basically form what? Definitely we must ensure that what is in our right and our left are the same thing. So hydrogen, and hydrogen doesn't just stand like this. The hydrogen stand as a gas. So we must balance. So we have 2 hydrogen on our left, right rather, and 2 hydrogen on our left to balance. But what about our charges? Here is already 2, alright, and here becomes 2 as well. You understand? So as to balance, that's why has to cancel. You understand? Because here is already neutral. Here is 0. So the charge at the left should be 0. Because here is 2, this plus 2, plus 2 plus minus 2, that's 0. So class, this is the reaction, and this is the reaction. That is how it works. I repeat, that is how it works. Class, is it understood? Are all these understood? Let me know in the comment. Are all understood? Are all these understood? I'm going to tell you guys something very vital. Please. Because we have about 3 factors that determines how, elements will be what? Preferentially discharged. The first one is the position of the ion in all of these series, class. And when do you use this? You use this when if the compound is in a solution and also they stated that it is dilute. Class, listen. Usually when the compound is in the form of a solution and they stated that it is what diluted. Class, I beg you, note what I just said. It will help me a lot. Alright? So let me give you guys another question. Describe the mechanism of electrolysis of dilute, let's say, magnesium or magnesium chloride. Magnesium chloride solution. Let me see what you guys can do. It's simple. Work this one out. Magnesium chloride solution. Alright, magnesium chloride solution. Magnesium chloride solution. Magnesium chloride solution. Magnesium chloride solution. Class, work out this one. Simple. It's very easy. Let's work out this one now. Class, listen, I beg you, listen to what we are saying. All these things are very important. So, class, are you following me? Class, are you guys following me? You guys should answer now. You guys are in answering. We'll work on your question. Chibueze, I'm coming now. Definitely you can now. You can send to my. I told you guys already. Send to my DM if you want to answer. You like to be sure of your answer. Send to my DM, alright? So there is something I want to tell you guys on this activity. I want you guys to pay attention, no. Alright? I want you guys to pay attention, Pay attention. Just listen. Listen well. There's something I want to tell you guys that is very, very important. There's something I want to tell you guys. Without wasting much time, you guys should work it out on the whiteboard. So because there is no time, let's get into another question. So this one now is let me change it. Remember the first one was dilute. Say no, dilute sodium chloride solution. Now this time around it is of concentrated. Class, pay attention. Concentrated sodium chloride solution. Class, I beg in the name of God, note all this. Listen, I repeat again. Whenever the question has dilute, your mind should basically, when you're preferentially, because definitely when there is a solution at the end, it tells that, oh, there's water, oh, so what would I do? Basically, I'll get, two sets of ions like this. So there is a competition. Which one will be preferentially discharged? Whenever it is dilute, you basically use, your position. But basically now, you mentioned the ion in the series. But basically, guys, whenever it is concentrated, this is what happens. You can see now that this compound is what? Concentrated. This is what will happen, though. Class, listen, let me wipe the board. I want to wipe the board, I'll tell you guys something. It is concentrated, this is what is happening here. When it is concentrated, this is what happening. So listen and listen well. It is concentrated, this is what happening. It is concentrated, this is what happening. Class, see, let me tell you. When it is concentrated, you should be very careful with what will be preferentially discharged in the anode. I repeat, whenever the question has concentrated in it, you should be careful on what will be preferentially discharged in the anode. I repeat again, whenever it has concentrated in it, the compound, whatsoever compound, you should be careful of what will be discharged at the anode. Let's start. So basically, it is concentrated sodium chloride, all right? And definitely, you know what should happen. Basically, we're going to get Na plus and also Cl minus, right? 1, there is water, so definitely it's going to give me what now? H plus and what? OH minus, right? So these are the ions, these are the ions. So basically what happens is that, these ones that are, this anode and this is cathode. So the ones that are positive will go, anode is positive, cathode is negative. So basically the ones that are negative come here. So Cl minus and OH minus, whereby this is what now? This is what now? Cathode is what now? Na plus 1 and what? H plus 1. Class, listen, no, I told you. So this is anode again, and this is cathode. So class, let me tell you, see, whenever you want to basically preferentially discharge, ions to their respective, the ones, this is a competition. So which one exactly will actually go with the anode and which one will actually go to the cathode? You see, whenever you see concentrated, take note of your anode. That what you're thinking is not the answer. You now be using the factor that will not determine it is the concentration of the ion. I repeat, the factor that will determine which one will preferentially discharge will be what the concentration of the ion. Now let me tell you. The ion, you still use this concept but it's not the opposite of your knowledge. Class, pay attention. Listen. Let me explain something. Let me explain something to you. Listen. I'm coming. Just listen, pay attention. There's something I want to tell you guys that is very, very important, so you guys should pay attention. Just hold on. All right. So guys, further look at it for the anode now. Anode is not these two guys that are competing. Normally, I told you if it's for dilute, it is basically the one that is lower that will be preferentially discharged. But this time around, it is concentrated. Actually, you now compare these two guys, which is more concentrated. It is chloride that is more. So basically, it's like you are doing the opposite of what you know. So due to the fact that normally this was one that would be preferentially discharged, but it is concentrated now. Just for your anode, cathode still remains the same. That the one that is lower will be preferentially discharged. It doesn't affect. As I said, you are taking note of your what now? Anode. So this one, cathode now. This one will be preferentially discharged because basically, H plus will be preferentially discharged now from your reaction. What about anode? It is this chloride. Because chloride ion is more concentrated than OH minus ion. Class, did you get? Chloride ion is more concentrated than OH minus ion. Alright? Take note of what I just said. Chloride ion is more concentrated than what OH minus what ion. Chloride ion is more concentrated than what the OH minus what ion. Chloride ion is what more concentrated than what OH minus what ion. Class, did you get what I said? Did you get what I just said? Alright, I'm coming, so I move further. Alright. Alright. So, in summary, whenever I see concentration, concentrated irrespective of the kind of compound, You basically have to be careful. So it's not opposite of your knowledge. Like the ones that are up are more concentrated than the ones that are down. So as you go up, your concentration increases. So this is more concentrated, followed by this, followed by this, followed by that. But due to the fact that we're comparing this and this, so which one is more concentrated? Chloride, ion. So and it is what at the anode. You understand? So you form your reaction. And anode is what? Anode is not loss of electron. So basically it's going to be Cl minus 1. Losing electron P minus, then we're going to get the gas form of it. You understand? Now balance and reaction. Here is 2, so here becomes 2. Charge is minus 2, so here becomes what? Minus 2. Do you understand? So this is your gas for concentrated form of that compound, guys. Alright? For concentrated form of that compound. For concentrated form of what? That compound. All these are very, very important. They are very, very important. So I've told you already, another factor that determines which ion will be liberated, discharge, preferential discharge, is the concentration of the ion. And you only pay reference to your anode. You only pay reference to what your anode, your cathode still remains the same. Class, are you following me? You only pay reference to your anode here. Your cathode still remains the same. Are you guys following me? Alright, that is for that. Oh, class, I believe you guys are following me. Oh, alright, I believe you guys are following me. Alright. Now, let us solve another question, all right? Let us solve another question. This time around, it will affect our, we're going to pay reference to our anode, our cathode, all right? The question you will see here, you now pay reference to your what? Your cathode, all right? It says, so, describe the of electrolysis of concentrated sodium chloride. It is still concentrated using mercury as cathode, guys. So this time around, we are using mercury as cathode. Mercury as cathode. Class, listen. Normally, this is what will form, but the natural knows that mercury Hg is the cathode. Class, normally, this is the cathode. And these are when the ions discharge in the cathode. He said question, they not say that, oh, mercury specifically is the cathode. So these are the guests. Normally now, I told you now, the ones that are, it doesn't affect those concentration doesn't affect what? The concentration itself doesn't affect cathode. You understand? Still the ones that are lower will be preferentially discharged. But due to the fact that they not stated using mercury as cathode, what does that mean? It simply means that one of the cathode will love mercury. And let me tell you, sodium loves mercury. So this time around, because of that, sodium ion will be preferentially discharged. Why? Because sodium loves mercury. Alright, sodium ion loves mercury what ion. Alright, mercury what ion. You understand what I'm saying? They love each other. Because of, so when this happens, they form what we call sodium amalgam. Sodium amalgam. I repeat, sodium ion loves mercury ion, so it forms what sodium amalgam. I believe you guys are following me. All right, so that is how it works. I believe you guys are following me, so that is how it works. I believe you guys are following me. That is how it works. As it has a great affinity. Amalgam, so that's how it works. So. Alright, it's very, very easy. It's very, very easy, guys. So cheap. Right? Very, very easy. Love means has a great affinity. Affinity for mercury ion. So they form what? Sodium amalgam. So this time around normally should have been this if mercury as electrode wasn't added at the cathode. Because they not specify the kind of cathode. That is why sodium was what migrated. Do you understand? But we have examples of other cathodes that are inert. So when you see those guys, like for instance, if they are said using platinum as cathode, it will not alter because platinum is inert. Using graphite as cathode, it will not alter because graphite is what inert. Do you guys understand? Pay attention. Alright? Pay attention. Alright? Let me give you more examples of inert electrodes. Alright? Of inert what? Electrodes. Using electrolysis. I've given you already. Platinum is one. Graphite is another. In terms of carbon, graphite is a carbon, right? So they can say using carbon as cathode. So basically carbon, so if example graphite, which is carbon, which is a carbon, platinum PT, you understand? All these are inert. They are inert electrodes. Inert electrodes will help you a lot. They are inert with electrodes. They will help you a lot, guys. You understand what I'm saying, right? They are all very easy. They are not difficult at all. You can see how we've been able to tackle all these. Alright? They are all very, very easy. So that is for that. So this is all we have to know on mechanism of electrolysis, guys. This is all we have to know on mechanism. There are others, alright? There is gold. Gold is chemically inert. Rhodium. There are more of them. Gold, rhodium. And maybe you see them in exam. Gold as a metal inert. Rhodium also inert. You understand? They're all inert. You get what I'm saying? So guys, that is for that. With all this said, we are done with the mechanism of electrolysis. So I'm going to end the live lesson here on this aspect, so we can basically next class when we'll start the calculative aspect of this subject electrolysis, get into some how electrolysis is applied. All right. So with all this, I see you guys and I see you guys. God bless you all. All right. So we've done a lot, and more classes will be held on this aspect. Maybe the next video class, live class lesson, will trash calculative aspect on electrolysis because they are all very easy. All right. So I don't. It is very long now. It's like I see you guys when I see you guys. Same time, like the video.